Let's look at the last question. The last question tells us that we should find the area by integration, which is bounded by the three straight lines, which is the first one is y equal to 4 minus x. The next one is y equal to 3x. The next one is 3y equal to x. So now these are what the functions that we have. And as I said earlier on, we need to find the meeting point of these graphs. At least two of them will meet, right? Two of them will meet. So if two of them will meet, what are we supposed to do? We are supposed to say that if y1 equal to y2, therefore this graph with y 4 minus x should be equal to 3x. And when we send this x here, we are going to get 4x equal to 4, and therefore we can say our x equal to what? 1. So this is our meeting point between this graph and this graph. And between this graph and this graph, let's see how it goes. So we can say that our 4 minus x is equal to, here let's make y the side, we can make y the side by dividing both sides by 3, and we are supposed to get x over 3. So we can say that 4 minus x is equal to x over 3. And therefore, per simplification, we are also going to get 12 minus 3x equal to x. To bring in this 3x here, we are going to get 4x to be equal to 12, and therefore we can say our x, you can see that our x is equal to what? 3. That's another meeting point between this function and this function. And the last meeting point between this function and this function, we are supposed to get 3x is equal to what? 3x equal to x over 3. And therefore, doing simplification, you can see that we are going to have 9x equal to x, and therefore we have 8x equal to 0, and then we have x equal to what? 0. Right? So these are the meeting points over here. These are the meeting points over here. So between, first of all, between the 4 minus x and then 3x, we had a value of what? 1. We had a value of 1. We had a value of 1. That's between, where's the 4 minus x? Here. That's a 4 minus x. And then we have a value of 1. What is the meeting point? So that means this one will be between 3x and then 4 minus x. 4 minus x. We have the x value to be what? 1. They will be meeting at x equal to 1. So what we can also do is that you can even plug in x value to the y2. When you plug in x value to the y2, you are going to get a particular value, and that particular value is going to give you 3. But that one later, I'll show you why we choose y2, which is 3x. But later on, let's see what we can do here. Now, since we are more focused on getting the limits on the x-axis, what we care about is finding the meeting point at the x-axis. And the meeting point for the first two functions is what? 1. The second two function is 3. And then the third two function is what? Also 0. So let's come here and then draw our graph here. So this is what we have. Let me draw the graph, this one, to make it okay. Let me bring here a bit. Yes. So now, first of all, indicate the meeting points. So the meeting point, let's see here it's 1. Or let me send a bit for it. Send a bit for it. 1, and then here it's maybe 2, and here it's also 3. So 1, 2, 3 for the x-axis, and then we have 0 as well here. So let's see what we can do here. At x equal to, we know that these are the meeting point on the x-axis. So we can also say that at x equal to 0, the first function will get y equal to 4 minus 0, y equal to what? 4. So we can say we are going to have 0 and 4. At s equal to 0, my second function will be y equal to 3, or the function value is 3 times 0, which is 0. So we are going to get 0, 0. And at s equal to 0, pardon me, my third function is going to be 3y equal to 0, and therefore my y equal to 0. So my third point is going to be 0, 0. So now I have these 3 points, one here, and then another one here. Right, so let's look at the first function. Remember that it's a straight line, but it has a gradient of -1, as we did earlier on. That means it will be slanted up. Let's say here is 4. That means it will be slanted a bit downward. I'll use the laser pointer here. It will be slanted a bit downward over here, because that is slope of -1. Here's rise of -1. So that is how it will be. And then the second one is also going to start at origin, right? It will be passing through the origin. The third one, it will also be passing through origin. So let's pick them one after the other. Remember that I told you that y equal to 4 minus x has a slope of -1. So therefore we can say that okay, let me change the pen. Therefore we can say that our graph will be here, because that's a slope of negative, right? Negative slope. So it will be like that. So that one makes sense. So let's focus on how we'll be able to get them to meet over here. So remember that the first graph here and then the second graph here has a meeting point of what? 1 at the x-axis. So let's also plot the second graph. The second graph at x equal to 0, y equal to 0, that means it will emanate from the origin, right? And then let's put the meeting point between this graph and this second graph in mind. So if this graph will emanate at origin, it has a rise of what? 3, which is a gradient, and the gradient is actually positive. This one, positive 3. That's the rise of 3. So if it has a rise of 3, we can see that it goes here, right? Over here, the gradient is positive. Let's assume that because the graph is not drawn to scale. No matter circumstance, I'm supposed to get this one to be slopey in such a way that I can get 3 around this point. But let's assume that this one is not drawn to scale, so we are not going to get that accuracy. So based on that, let me get something here. Yeah, I want to draw into scale. So we assume that the meeting points are seen. This is how it's supposed to be. And then the next graph, it's the third graph. And then as I said, at s equal to 0, y equal to also 0. So that graph also emanates at 0, 0. This is the origin. It will emanate from the origin. And if it emanates from the origin, remember that we did some analysis here. The meeting point between this first graph and then the last graph here, we did it over there, which is what? 4x equal to x over 3. And at the end of the day, we were able to get something like x equal to 3. So if this is x equal to 3, this is it. So we are supposed to come there. And then the meeting point between the second graph, which is y equal to 3x, and the third graph, which is, so this is my y equal to 3x. This is my second graph, and this is also my y equal to 4 minus x. So this is my second graph. This is my first graph. The last graph when we did the analysis, which is 3x equal to x over 3, and at the end of the day we got x equal to 0, that means that this second graph here, this one will meet the third graph that I'm about to draw at x equal to 0, which is this point. This is origin, right? It will meet it over there. And then the third graph, as when I did the analysis for the first graph, it was meeting at x equal to 3. So we can see that this is passing at the origin here, but it's supposed to meet the first graph up at this point. So the meeting point, not drawn to scale, is supposed to be like this. So at the end of the day, you can see that you have a shape, and that shape is supposed to be between these three graphs. And then you are done with coming out with the graphs. You are done with coming out with the graphs. But I will later come and show you how we'll be able to use this graph to find the area under the curve. But remember that after being able to come out with a graph, you have also been able to come out with the limit, and the limit will also start from 0 here, because here is 0, the meeting point 0, and then 1 here. I will tell you the reason why it's 1, and then also 3 here. So this is very important, so I will come back and then we will solve such questions. So finally, this is a quick okay, I think I have not actually solved some examples with you, so I'm coming to solve some examples so that I can show you how, or guide you on how you'll be able to solve and get the answers for these trial questions. So look forward for my next video.